Okay, so we're just going to cover Pascal's triangle and how it relates to binomial distribution. Do you remember how Pascal's triangle starts? We have the number 1 and then 1 and 1. Excellent. Okay. Think of this as being one term in itself. So here's one term. In other words, think of it as a monomial. That's what monomial. Oops. Spelled that wrong. There we go. Monomial. Mono standing for 1. This step here, think of this as two terms, also known as a binomial. Make sure I spell it right. There we go. Okay. Now we know as Pascal's triangle goes on, we end up actually adding interior numbers. So the 1's continuously stay on the outside. This becomes the value of 2, 3, and how many terms do we have here?
3 terms.
3 terms, known as a trinomial. Okay. Well, this will continue all the way down. Now, in our question, they've given us the value of x plus y to the power of 6. Now, how many terms are technically in this right now?
2.
2. And that puts us at the second level. That would be a binomial. In other words, binomial distribution. If we'd done it as a monomial, it would change things. And if it had been a trinomial, it would have changed things even more. Okay, so here's our binomial distribution. Well, Pascal's triangle, we know that technically as a binomial, this is only the very first level. This would be just the first level of binomial. This would be set like a binomial to the power of 2. Okay? So the next level, which is 1, 3, 3, 1, is technically to the third power of a binomial. But we have to go to what value?
6.
So we're going to have to try a couple more rows of this, right? The next one will take us to the fourth, which will be, you want to read it out for me? 1,
4, 6, 4, 1.
And that's to the power of what?
4.
Yeah, a binomial to the power of 4. Next one would be
1, 5, 10, 10, 5, 1.
Yeah, power of
5.
Right. And then
1, 6, 15, 20, 15, 6, 1.
and that would be the power of
6.
And how far do we have to go?
7, 6.
Yeah, we just got to go to the power of 6. Now, it just so happens in Pascal's triangle, it happens to be the 7th level. Okay, so this is level 7, but it's the same as a binomial to the power of 6. That's what this level is here. Okay, now these values actually stand for our coefficients. In other words, what this is telling us is there will be 1, 2, 3, 4, 5, 6, 7 terms when we do this to the power of 6 as binomial. Okay, so there will be 7 terms. And you did all of the exponents correctly also when we went through this. You wrote down that in our very first term, we know we would have x to the power of 7 times y to the power of 0. Right? What we didn't have, though, are our coefficients. So what would the very first coefficient be?
6. 1 and 6.
Well, it would just be 1 for the very first term. Then we would add to go to our next term. So we have an addition sign in between here. I'm just going to stop. Our next term would technically be x to the power of 6 and then y to the power of 1, right? But what would be our coefficient in front of that one?
15. I mean 6.
6, that's right. We take the second term, right? So this is where our second term comes. And then we continue that pattern all the way out, just like you had done. So what would the next one be?
15.
Yeah. Then x to the power of?
20. I mean x to the power of 5 to the y 2.
Good. Next one would be?
20 to the x 4 3.
Yeah, x4, y3. Then what?
15 x to 2 to 5.
Not quite.
Oh, so 3 to
yeah, that's right.
3, no, 3 to 2.
2.
5.
Our y is going up.
3 to 4.
3 to 4, yeah. x3, y4. The next one would be?
6 to 2
yeah.
to 5.
y5. And then finally, the very last term, what would that be?
1 to x6.
I think we missed something there. Oh, I apologize. We did make an error. What was the highest exponent here?
6.
Yeah. So should our first one been to the power of 7? No. There should have only been 7 terms. Now we've counted on the y's properly, but we haven't counted the x's properly. Because it's to the power of 6, the highest value when we do exactly. So x can only be multiplied by itself 6 times. So this would be x6, 5, 4, 3, 2, 1. What would this one be?
1 to x6 to y0.
Not x6. Or x is counting down.
Oh, sorry, 0.
Yeah, and then y6. Exactly. Okay. So that's how we use Pascal's triangle to help us out with. Instead of actually calculating that all ourselves, we can do this the quick way.